Have you ever wondered why ships and planes famously get lost in the Bermuda Triangle? It's not just folklore, there's a tangible scientific reason. A baffling magnetic anomaly. We're going to break down exactly how this natural distortion throws compasses into chaos and finally demystify the science behind one of the world's most perplexing navigational hazards. For centuries, sailors have reported strange experiences while passing through the Bermuda Triangle. Compasses spinning wildly, ships veering off course, and navigators baffled by instruments they had trusted for survival. Some of the most famous disappearances, like Flight 19 in 1945, involved trained pilots who became disoriented when their compasses began malfunctioning. To the outside world, these cases seemed inexplicable, sparking legends of supernatural forces, alien abductions, or even portals to another dimension. But what if the truth is not supernatural at all, but scientific? The Bermuda Triangle sits in a region of the Atlantic Ocean between Florida, Bermuda, and Puerto Rico. What makes it unique is not just its reputation, but the measurable magnetic anomaly that scientists have detected there. This anomaly is not constant across the entire triangle, but in certain localized zones. Compasses don't point toward magnetic north as they should. Instead, they deviate sometimes subtly, sometimes dramatically, causing navigators to make errors without even realizing it. To understand why this happens, imagine Earth's magnetic field as an invisible shield wrapping around the planet. It's generated by the movement of molten iron deep in Earth's outer core, creating north and south poles. Most of the time, compasses align with this field, pointing toward magnetic north. But the magnetic field is not uniform. It has ripples and irregularities, almost like dents in an otherwise smooth fabric. These irregularities are what scientists call magnetic anomalies. In the Bermuda Triangle, one of these anomalies occurs. Picture yourself holding a compass near a magnet hidden under a table. The compass needle swings strangely because the local magnetic pole interferes with Earth's broader field. That's exactly what happens here. Localized rocks beneath the ocean floor, carrying their own magnetic imprint to store compass readings. Geologically, the seafloor in this region holds the key. Millions of years ago, volcanic activity shaped the seabed. When molten lava cooled, the iron-rich minerals inside locked into alignment with the Earth's magnetic field of that era. This is called remanent magnetism. Over time, as the planet's magnetic field shifted, those rocks retained their ancient orientation, creating zones of magnetic interference. So when a modern compass passes over these spots, it's essentially caught between two sets of instructions: the current magnetic field of Earth and the ancient frozen field within the rocks. Now let's think practically. For an old wooden ship relying solely on a magnetic compass, even a small deviation could mean drifting miles off course over time. For a pilot flying over open ocean, a compass swinging just a few degrees off north could cause fatal disorientation. In areas like the Bermuda Triangle, these natural deviations were magnified by human error, bad weather, and sometimes lack of backup instruments, making tragedies more likely. A compass itself is a simple yet elegant tool. It consists of a magnetized needle that aligns with Earth's magnetic field, pointing toward magnetic north. However, true north and north pole use in maps is not the same as magnetic north. Normally, navigators adjust for this difference, called magnetic declination. But when you add an anomaly into the mix, the compass no longer points consistently in relation to either true or magnetic north. Instead, it sways toward the influence of local magnetic fields in the rocks. This creates confusion, especially for someone who does not realize they are in an anomalous zone. One common myth is that the Bermuda Triangle is a place where compasses point to true north instead of magnetic north. While this has been repeated often, the reality is more nuanced. Compasses deviate because of localized geological influences, not because the laws of physics suddenly reverse. The anomaly is a measurable, natural effect of geology. Fortunately, modern technology has transformed navigation. Today, ships and planes rely on GPS satellites, inertial guidance systems, and digital mapping. These tools are immune to the quirks of magnetic anomalies, making large-scale disasters caused by compass deviations far less common. Still, smaller boats or aircraft using older equipment can experience the effects of the anomaly, reminding us that the mystery is still very real on a human level. Scientists continue to study Earth's magnetic field because it's not fixed, it drifts, shifts, and even reverses polarity over geological time. Mapping anomalies, like the one in the Bermuda Triangle, helps researchers understand not just local hazards, but also the broader dynamics of Earth's magnetic system. Every compass glitch in the ocean tells a story about the history of our planet's interior. So while the Bermuda Triangle may not hide supernatural forces or extraterrestrial portals, it does conceal geological and magnetic secrets beneath the waves. Its strange compass readings remind us that Earth is alive, shifting, and ever-changing. The mystery is not one of monsters, but of magnetism. And in that sense, the Bermuda Anomaly is not just a navigational hazard, it is a window into the invisible forces shaping our world. The next time you hear tales of ships vanishing or compasses spinning wildly in the Bermuda Triangle, remember this: the truth is both less sensational and more fascinating. It's the story of how rocks beneath the seafloor, frozen in time millions of years ago, still tug at our instruments today. Science, not superstition, is what demystifies the Bermuda Triangle. And that, in itself, is a wonder worth exploring.